Good morning, Year 5. Miss Biggs here. Welcome to your Thursday's maths lesson. Please record today's date and learning objective in your book. Today we're going to add fractions within 1, just like yesterday, building on those skills and recording them in our books. Please record today's flashback 4 in your book, numbers 1 to 4, and the time over here. Pause the video while you do that, and then come back to me with your blue pen ready to mark. Let's see how you did. Here are your answers. Pause the video while you mark. Remember to blue pen reflect on any that you need to. Let's move into today's learning. So today we're building on our learning from yesterday, adding fractions within 1. Let's do a quick warm-up activity, building on yesterday's learning. Pause the video while you have a go. Let's see how you did. So you'll notice with this one we've got one of our equals signs. So this equation must balance with this equation. Well, this one we know, so let's work it out. 7/10 add 2/10 would be 9/10. That means this side has to be equivalent to 9/10. We have 3/10 already. That means we need another 6/10 to be able to work out what fifths we need. So we need to change 6/10 back into fifths. What do I do to 10 to make it into 5? I halve it. So I do the same to my numerator, halve it, and that's 3. Moving on to number 2. 8/24 is equal to how many sixths? You should see that we need to change 6 into 24ths. What do I times that by? 4. So I do the same to the 8. I do the same to this number to get to the 8. So what number times by 4 would be 8? 2. Moving on to number 3. 6/9 is equal to 2 over something. What would I do to 6 to get to 2? I divide it by 3. Do the same here. Divide 9 by 3 is 3. Let's learn. Building on yesterday's work with our fraction strips first of all, before we go into our more abstract form. Let's check. 1/3 add 1/6. Now remember, the key is we need to change the fractions so that the denominators are the same. So we're going to change 1/3 so that it becomes sixths. What would I do to 3 to make it into 6? Times it by 2. Do the same to your numerator, times it by 2, and it should be 2. Let's check. You can see here when I've split this into 6 that 2 of them are shaded. So that's 2 6. Add the 1 6 we had already. Now we can see that's really easy to add together. 3 6. Now if we move this up to here, you should be able to see now that that takes up half of the line. So 3 6 is also equal to 1/2. 3 goes into both of these. 3 goes into 3 once, and 3 goes into 6 twice. That's why 3 6 is equivalent to 1/2. Let's pause the video and have a go at this one. 3/4 add 1/12. Look for your common denominator. Think what you're doing to the strip. Shall we see how you did? So we can see that quarters need to change to 12ths. What would I do to 4 to make it into 12? I'd need to multiply it by 3. So I do the same to the numerator, times it by 3, and it is 9. So it should be 3/4 should be equivalent to 9/12. Let's check. Split our bar. Do we have 9/12? 1 2 3 4 5 6 7 8 9. 9 out of 12 altogether. So it's right. So I now have 9/12. Add 1 more 12th. That's 10/12 as an answer. We could leave it there, or we could say, is there a number that goes both into 10 and into 12? 2 goes into both. So 10 divided by 2 is 5. 12 divided by 2 is 6. So it's equivalent to 5/6. Let's try it in a word problem. Annie runs 7/20ths of a route. Ron runs 2/5 of the same route. How much of the route do they run altogether? Altogether means I need to add. So I'm going to add those two fractions together. But you can see that they're not the same denominator. I need to change fifths into 20ths. Pause the video and have a go. Let's see how you did. What would I need to do to 5 to make it into 20ths? I'd need to multiply it by 4, correct. So I do the same to the numerator. 2 times the 4 gives me 8. 8/20ths. Now I can do 7/20ths, add 8/20ths, which is 15/20ths. Well done if you got that answer. I wonder if you can think of a number that goes both into 15 and into 20. Yes, 5. How many 5s go into 15? 3. How many 5s go into 20? 4. So it's equivalent to 3/4. Well done if you found that. Your turn, please, to have a go at questions 1 to 3 on your worksheet. You could use this fraction wall to help you at any point with equivalent fractions. This is how I'd like you to lay your work out for these questions. Because we need the fraction strips, we're going to record these directly into our books. For number 2, you can choose to stick it in your book, or you may wish to write it down neatly so you can do your conversions. When you've finished all the way to the end of number 3, pause and come back to me. Let's move on. Have a look at this one. How many thirds add how many ninths equals 7/9? So at the moment they are not the same. So we apply our principle of having to have the same common denominator. We're going to convert our thirds into ninths. So we need something ninths add something ninths is 7/9. Could it just be any old number? For example, could it be 5 add 2? Have a think. Let's have a look together. Well, we have to think. To get back from our ninths into our thirds, we'd have to divide by 3. But unfortunately, the 5 does not divide by 3 to give us a whole number. So this is not a possibility. So what is a possibility? What will divide by 3 that's less than 9? We could have 3. 3 will divide by 3 to make 1. 1/3. So 3/9 would become 1/3. What other number divides by 3 that's less than 9? 6. 6/9. And then if we divide by 3, that 6 divided by 3 would become 2. So that would be 2/3. Let's see what we would have to add to that. 3 add 4 would make the 7. 6 add what would make 7? 1. Now the ninths, you can see, doesn't change, but these bits do. So if it was 3/9, we divide it by 3 to get back to thirds, so that will be 1/3, and this doesn't need to change because it's already ninths, so it will be 4/9. We could also use the other one. Now this would be 6/9, but we need to convert it back to thirds by dividing by 3. So 6 divided by 3 is 2/3, and the ninths don't need to change. Which part went with it? 1/9, sorry. Well done. So 2/3 add 1/9 is the same as 7/9. This is what we call an addition wall. For example, if I was going to do it, this brick, 3, add this brick, 5, make the brick directly above it, which is 8. We're going to apply this principle to help us with doing a fraction addition wall. Let's have a look. Now here you can see we've got 1/5, 3/10, and 3/20, but none of the denominators are the same. So before we start, we know we need to change the denominators so they are all the same. 5, 10 and 20 all go into 20, so we need to convert it to 20ths. 5 times 4 is 20, so 1 times 4 is 4/20. 10 times 2 is 20, so 3 times 2 is 6. These are the fractions we're now going to work with. To get this one, I need to add these two together. 4 add 6 makes 10, 10/20. This one, remember, this is what we're adding. 6/20 add 3/20 makes, what do you think? 9/20. And to get the top brick up here, we need to do 10 add 9, which makes 19/20. Are there any there that you think you could change? Did you spot that 10 is half of 20? Therefore, 10/20 is the same as a half. Well done if you spotted that. Your turn, please, to have a go at questions 4 to 7 on the worksheet. To help you with this, I've shown you how to write it up in your book, so you are not sticking in these questions, you are writing them up in your book. Pause the video here so you can see exactly how to lay it out to help you with that learning. Continue to the end of question 7 and then come back to me for the red level challenges. Here are the red level challenges. You stick each one. There are 3 today, 1, 2 and 3. For the first one, it matches what we've just been doing, so be careful with that. In the top one, you've got 16th add 8th making 16th, so think what you might need to change that into before you work back to change it back to 8ths. And the same with this one, they're 20ths apart from this one, so change it to 20ths, but remember to do halving to get it back when you need to. Okay, with this one, I've given you some sentence stems to help you answer why Annie is wrong. So Annie is wrong because, what should she have done? And then this one, what's Eva started by doing? What does she now need to do? And then Eva will then shade what, how many fractions, and then we'll have what as a fraction all together. Use today's learning to help you do these challenges. It's all based on today's learning. Good luck with these challenges and see you for your learning tomorrow. Goodbye.